So how many of our kids are robotic in their long division, and how many kids are truly able to be flexible in their numbers? By the way, if you don't know if it works out to be, what do I do with that remainder of 1, right? How many kids? I don't know what to do with that remainder. Of course they don't know what to do with the remainder, because they don't even understand why the steps are the way they are. What happens when I stretch it out? Look at this. If we stretch this out by multiple, 600 plus 9 tens plus 6 tens, there's 1 more left over, all divided by 3. Look how we wrote it.
Right.
It's already put in there. There is no remainder of 1. It's always a fraction. That's why when my kids, even at home with their homework, they go, oh, where do we remainders? And I go, okay, I want to follow what you're teaching, right? Because interventionists in us, I cannot undo what goes on in the core instruction until it's mastered. Right? If you try to do an intervention when the core isn't even understood yet, now I got a kid not understanding 2 ways to do it. Right? So we continued down the way that she was working with, which is a pull down, and then I made sure that she understood 1 divided by 3 is the question. It's not how many 3's go into 1, it's 1 divided by 3. That allowed her to write it as a fraction. I know you're thinking, yeah, it's the same thing, but nobody writes a fraction writing it up. I've never seen a kid go, oh, 1/3, so 3 and 1. It always is numerator the denominator. So we would make sure that she could rewrite it and re-say what's happening there. So in this case, this is just yet another way that you can see how long division could be done if you understand place value. All right, I'm going to start drifting away from place value because I want to finish with an explicit instruction idea. Please understand this part. If anything, I hope the place value stood out. Boy, Witzel really likes this place value a little too much, right? That's what you should leave thinking. And the reasons why? In the National Math Panel, we had a lot of mathematicians who were from international groups. And you know what they all said? The basics of mathematics all revolve around place value. And so when we were having our conversation, right, my children were in utero, when we're having a conversation and all these mathematicians are talking, right, it's a congressional panel. Why all these top research mathematicians in the nation? And why were they pushing this? They're saying because our number system's a mess. It's the English language is the first barrier you have to get past before you can teach math. Which is a reason why they were saying Australia lags behind, New Zealand lags behind, United States lags behind, UK lags behind. The only reason why Singapore does not is because even though Singapore is English first, they have incorporations of the Asian languages built in. And how do Asian languages read their numbers? 110-1, 110-2, 110-3, 110-4. 123 is 100, 2 tens, 3 ones. And when they sing-song it, it is a 123, 124. They have a sing-song version. But when they point to that number, they say it by place value from left to right. So I'm not saying it's going to happen overnight. But I do hope that if you have young children at home, you begin that process. And as we work with our children, we start incorporating that language more often. We've done this before. There's no reason to jump into it. This is all place value conversation. Oh, by the way, Chinese textbooks. Chinese textbooks are all place value based. Of course, because their language system is place value based. All right. So we did our race to 100. That was a good job. Okay, so this comes up. This is my 3rd grader, and I was so lucky. When my youngest was in the 3rd grade, she had just, I know you're a better teacher than she was, but Kristen Rhodes was a fantastic, that's on camera, it's okay. She's now a principal where I'm at. She was an absolutely amazingly brilliant 3rd grade teacher who could put up with my personality. My youngest is a mini me. So this is showed up on the board. It's 243, but the question in the book says, how many hundreds are in this number? And the book says the answer they want what? 2. But that's not the right answer. So my daughter, who understands place value early, what does she say the answer is? 2 and 43 hundreds are in that number with a little head cock. And so Miss Rose looks at me. There is a 2 in the hundreds place in that number. She starts trying to rephrase it. But the next question in the book says, how many tens are in that number? There are not 4 tens in that number. There are at least 24 tens in that number. 24 tens and 3/10 of a 10 are in that number. So what I'm getting at, guys, is be careful of your own textbook. Your textbooks are not up to the level of the expectations of a proficient or advanced student. I'm warning because if you know your math, you'll get more and more ticked off by textbooks every day. Every time I open another one, I see Kramer's rule for determinants. I see Kramer's rule written 3 different ways in 3 different textbooks. Which means if that kid's jumping around from school to school, he's going to hear something different no matter where he goes, and it will never progress. We've got the same problem. We've got to be on the same page. All right, so you can use this again and again. This is what I'm getting at now. We're going to talk about systematic instructional principles as we leave here. And I'm going to say we're not going to do chicken teaching. Right, y'all do chicken teaching? You've done chicken teaching, haven't you? All right. All right, I've shown you 3 ways to do the problem. Do the next 422 on your own. And then what are you going to do for the rest of this class? Okay, can you move the next one? Now put your hand down, try the next. I can't even do this one. I'll be right there. And you go from student to student. And you just cluck like a chicken. All day long. No, okay, I'll be right there. Hey, shh, hush up over there. Get back to work. No, stand over there. No, you don't do it. You do it this way. What you've done is you don't do class instruction anymore. You become a tutor. Chicken teaching means watch out. If you become a tutor, stop, time out, eyes on me, pencils down. You too, pencils down. And then stop talking over there, right? And you get them all back together, and you teach the entire group. Sometimes when we do observations, I know this, when I observe teachers for Teacher of the Year, something like that, we frequently run into chicken teaching because that makes the teacher go, I was really busy in class. And I keep saying, whoa, you won't make it. You're going to be exhausted. First, you need to wear sneakers, knee pads, and a helmet because you're going to hit things as you keep going. What we need to do is work on systematic instruction. So here's what I'm going to do with you. If you don't mind, come up here. You can come from your table, grab a whiteboard. You won't need it often. And grab 1 marker. I do not have enough erasers. I didn't steal enough bathroom tissues. But grab, for everybody in here, grab 1 marker. Grab 1 board. One per person.
Okay, sorry.
That's all right.
We're like 1 to 5 elementary schools in the whole state. I'm not saying that's a great thing that we're focusing on teaching the kids about every other country. I'm over 50, so I have a little issue with
So that was
so don't get excited. You guys doing it? There's other stuff to tackle.
Alright. If you've never seen kid snippets, I hope you like this. Hold on. I want to say, hey, hold on. Do you experience kid snippets on a daily basis? Hold on.
First thing tell you the direction. What form take away 5. 1, 2, 3, 4, 5, 6. Take away. What's 6 take away 1? No. You take it away. So you take away 1 out of 6. How much do you eat? 4, 5, 6, 7. No. 1, 2, 3, 4, 5, 6, 7, 8. 8 and one more. And add one more. Is equal. 1, 2, 4, 5, 6, 7, 8. 1 equals, it makes 9. See how you take away 1 and it equals 1. Do you get it now? Yes.
Anybody live that world? All right, so obviously explicit instruction is where this starts. So you can look back through and find all the research on explicit instruction. Everything seems to be trumped in comparison to it. That is the strongest point of evidence we have at this point in mathematics education, is that explicit instruction works. Not for certain populations, which I get all the time. That helps those kids. No, it helps all kids. And we have the research to prove that. If you disagree, you got to go to the National Math Panel, go to What Works Clearinghouse, take a look at the Center on Instruction, go to a research think tank. I have never seen, look, it doesn't work. I've seen people argue that something works as well as it does, but I've never seen anybody have a solid argument that it works better. So that's what we're going to play with a little bit. Oh, if you are looking for this on the PowerPoint, all you have to do is click. Oh boy. All I used to be able to do is click. Okay. And you can open up the IES practice guide itself. There it is. And you can actually read pieces of it if you want to have discussions on how this all works. You can even go through it and click on any of the details in there. Like if you want to have more information on visuals, you see that really hot guy giving an interview on it, or interventions on it, and you get all these, hot, no, it's me, but that's okay. But, no one thinks I'm hot, it's okay. I have one child who goes, I think you're great, Dad, thank you. The other child, no. But you can always click on that research, because this is U.S. Department of Ed put this together. You can read about why we're saying explicit instruction works. But let's get started. Here we go, your turn. Mary received, on your own or in groups, Mary receives half the Halloween candy that she collected with her brother. However, her mom has mom tax. Okay, that's important. Mom tax for Halloween candy is important. Mom divided Mary's candy into 3 groups for the remaining members of the family. How much the total amount goes in each group? All right. I'll give you a couple minutes here. How do we do this? What happens?
Mom divided her half, so it would be into 3 groups. 3
So how do we solve this one? I see pictorial diagrams. I see models. Yep. Good visual models on it. So what essentially is going to happen here, we're taking 1/2 of the candy, and what's going to happen to that 1/2? It's going to be divided into 1/3. Each one of those thirds, how much does it relate to the whole? It's going to be 1/6 of the whole. Basically, you're taking 1/2 divided by 3. Okay? All right, hold on. I want to get more complicated because that's exciting. Same visual approach for you guys. Susan also goes trick-or-treat and collects 2/3 of the total amount of candy with her siblings. Her dad tax, Dad splits that amount into groups of, whoa, that needs to show up. How do I get that? 1/9. Yikes. Somewhere over here is supposed to say 1/9, so I'll go with it. That's what's missing from that picture. It's on there. So Susan goes trick-or-treat, collects 2/3 of the total amount of candy. Her dad wants to split that amount into groups of 1/9 each. How many groups of 1/9 would there be? What's the mathematics that's going on here? Stay. It won't be 3. What do y'all think? So the question is, I've got 2/3 of the candy, and I want to split it up into groups of 1/9. How many groups of 1/9 will I have? So I hear 6. This is what mathematically is occurring. I've got 2/3 of the candy, and I'm breaking it up into groups of 1/9. How many groups of 1/9 do I have? Now, I'm going to show you my way of thinking through this. I know that your teachers forever, oh, I knew you wouldn't last. Okay, I know forever everybody says, you know what? You only find like denominators when you're adding or subtracting. So I'm going to challenge that notion today. What I'm going to do is I'm going to find a like denominator because I want 2 divided by 1 and 3 divided by 9. But that's really weird down here. So what I'm going to do is I'm going to get an equivalent fraction, 6/9 divided by 1/9. What's 9 divided by 9? 1. What's 6 divided by 1? 6. What's my answer? There are 6 groups. So this way you don't get stuck into that invert and multiply y. I have no idea, but that's what my teacher does. And next time we meet, I'll show you why invert and multiply does work. But I want to make sure that I dispel that you only do this procedure for this piece. Make sure we go more broadly. Yes, ma'am.
What do you do when they can't do the
equivalent
denominators though?
Oh, for the multiples?
Yeah, so because my thing is, here I am, I'm multiplying by the reciprocal. That's.
Well, I know this sounds mean. In January, we're going to focus directly on rational numbers.
Okay.
For now, I'm just showing one approach. See, that's okay. We're going content, and I'm trying to show systematic instruction. That's okay. So this is, I go, but you know what? I would really like, how do we do this more commonly, all the time? Well, that's what we're going to do today. We're going to practice using that approach. But to do so, we're going to do a couple of pieces here first. Oh, here we go. Let's look down here. What is an equivalent fraction of 1/2? What I'm going to do is I'm going to snap, and you're all going to yell it out. Right at that point, 2/4. Ready? So 1/2. What's the equivalent fraction?
2/4.
Let's try this one. 2/3. 4/6. 1/5. 2/10. 2/5. Wait for it. Come on, those of you who know S already, you knew I would do something like that. All right, 2/5. 4/10, and then 3/4. Oh, someone's a stinker said 9/12. For everybody else, yes, 6/8. I love you. Ooh, you're a stinker. But I love it. Okay, it's all correct. For a warm-up, the purpose of your warm-up is to make sure that I lead them into what we're going to be doing for that day. So this part, stopwatch me. Oh gosh. I'm just going to move it just because everything I think is about to be squished on the corners. Everything's going to be squished on the corners. All right, hold on. Let's get ugly. You think this moves the box? Oh, of course. Okay, that was good. See, logic might not happen. Okay, 2/3 divided by 1/6. I want to try to tackle how many 1/6 go into 2/3. To do that, I'm going to have to first focus on, now look what happened because I moved the box. All right, now I need to move both sides of the box. Okay, this is going to be fun. As much as we love technology. All right, I think that, let's see if it shows. Wait, and it's close. We'll go with close. All right, first I have to check, are the denominators equal? If they are, it is easier to use. So in this case, 2/3 divided by 1/6, note the denominators are not equal. So what do I need to do? I'm going to rewrite equivalent fractions until the denominators are equal. So 2/3 is the same as 4/6. 6 and 6. My next step to doing this is I'm going to ask myself, are the denominators equal and they can divide into 1? So I'm checking my work and the answer is yes. The next step is, oh boy, okay, the next step is calculate the numerator. So if I know 6 divided by 6 is 1, 4 divided by 1, this case the answer is 4. Then my last step is take note of the answer is 4. So when we're going to practice these together, we're going to use, for this fraction, we're going to use fract. F-R-A-C-T. Focus whether the denominators are equal. rewrite the equivalent fractions, ask yourself if the denominators can be divided by 1, calculate the numerator, and take note of the answer. Fractions. We're on the same page? Let's try it. Let's do a couple back and forth together. Oh, we can see them all, yeah. Let's do a couple back and forth together. For the first one, I have 1/2 divided by 1/4. First part, are the denominators equal? No, so what do I need to do? Rewrite. Which one makes more sense to rewrite? Let's go with the 1/2. We can't do the 1/4, but I'm going to choose along the smallest number in the denominator. What's an equivalent fraction of this one? 2/4. What's 2/4 divided by 1/4? Well, and I would write this out, I don't have a board with me. But I would say 4 divided by 4 is 1, I would check that, and then I would say 2 divided by 1 is 2. My answer would be 2. Okay, let's try B here. 2/5 divided by 1/3. It's going to get a little uglier here. Are they the same denominator? No. Okay, let's rewrite. I typically like to start with the smallest number because I'm working on multiples, but anyway, another day, another time, right? But that's January. But I'm going to rewrite this one. That would be what? 2/6 this time? So guys, I would have to go back and forth. What is my multiple I will end up working with? 15ths. So I'm going to end up with 10/15ths divided by 5/15ths, right? So I'll then say, okay, now we have 15ths. 15 divided by 15 is 1. 10 divided by 5 is 2. Well, would that be 2? Oh gosh, sorry. It would be 6. Sorry, my multiplication is good to me too, right? 6. I knew it. 2/5 divided by 1/3. So if we don't know our multiplication, remember we're going to cover this in January. What's an equivalent fraction of each, we said? 15ths. So what is this one? 5/15ths, and this would be 6/15ths. I was doing 2/3 and making it times 5, which was crazy. So what do I get here now? 15 divided by 15 is 1. What's 6 divided by 5? 6/5. So what's my answer? 6/5. Make sense? Okay. For the next one, I'm going to move things so I can see what my next example is here. 5/6 divided by 1/2. So let's do the next one. 5/6 divided by 1/2. First thing I check, are the denominators the same? No. Okay, so I need to have some equivalent fractions in here. Let's start with the smallest number. It's easier to work with. Let's make that, oh, you know what? If I do that times 3, numerator and denominator, what am I going to get? 5/6 divided by 3/6. I check. Will that equal 1? Yes. So what's my answer? 5/3 divided by 1 is 5/3. All right, for time's sake, does this make sense?
Yes.
Once we practice this going back and forth, what do we then get to do? I'm going to have to get the big screen, hold on. We then start working in group practice, which means we go back and forth. We've already started that because we're adults, but with children, that last step would have been all me. And when they stepped in, I would have asked for multiplication checking, things that I know that we should be able to do. And I check for that. Now it goes group practice, which means this week, all back and forth. What do I write first? What do I write second? Make sense? Once we get through this step, partner practice. We did green and gold earlier, so I would say greens. You have H, gold, you have I. Work on your problem, and then they would go through and I'd say, green, stop, time out. Green, explain to I what you're doing. And then they would go back, great, I. Green, explain to gold what you're doing, and then we say, for I, gold, explain to green what you're doing. At this point, I start seeing more problems emerge. Now, I don't get to travel often with these, but if they're working on their whiteboards, I won't have the time to get to every kid at this point, right? But I need to make up some time, so I'll go through and I'll say, great, Willie, if you could, go up and explain H for me. On the back of your whiteboards, TSA, I just can't travel like this, put some magnetic strips on the back of your whiteboard. What is he going to do? Well, he will come up, pop his board up, and explain the steps. What we found is that if I asked him to come up and do this, guess what he ended up spending almost all of his time doing? Writing, which means the whole class starts erupting. But if he's got a magnet strip on the back, he can pop his board up and explain the steps. What does that give me time to do? I've already seen you can do it. What does that give me time to do? I'm now going back to that kid who was like, I don't know where. I get the kid who goes, 1, right? I'm back to that kid. So I'm back to help him out. If I've got more than one kid to go to, stop, time out, and I go back a step. And we do more of these problems. Which means I get back to partner practice. Partner practice means every student speaks every day. This makes every student have to verbally explain the problem step. So if I've got a class of 6, I can hear everybody do it. If I've got a class of 50, like I told you, right? I got a class of 52. I couldn't hear everybody speak. So I had to have them all. With LD, we had 20 of the 52 students had learning disabilities in that room. It was a cafeteria with 12 round tables. I had to get some way to get them to speak, but I couldn't monitor it all personally. So I had a lot of partner work back and forth. That allows me to then hear chat. My next step for you guys. After we get through partner work, I have my non-example, and I say, okay, which one of these is done wrong? And so now my students are looking. This means this is the most common error pattern I've seen in my past teaching. So look it over, which one of these is done incorrect? Red, why? Which step did they miss? That equivalent fraction one, right? They've got this, but they need to keep going. I need to probably see tenths out of this. So I know this is my error, which means before they go, you better have a slash through it so the kid who wakes up on you and goes, oh, that's how you do it, right? Now I need him to come back, so I put a big cross through it and say, don't do it this way. But that's my most frequent error pattern I found with that approach. Okay? They've got the wrong comment. Well, look, I got 2s now. Oh, boy. That's not what we're going for. That means they really don't understand the definition of the denominator. Okay, step after that, then they go independent. Before they leave, here's the exit slip on your board. Do this one on your board. So that's what I would do. I do everybody, before you leave here, I've got 3 minutes. Do it on your board. I'm not going to spend 3 minutes. Do the best you can. And Nancy, 3 minutes. And then we're done. So what I would do is after this, I would have a time set to it, and I know I'm pushing it now, but I would set a time to it, and then of course my terms are. All right, everybody, at your boards, board to, right, 2 hands on board to forehead. Yours are new, but you can see grease marks on mine. And what am I going to do with mine? I'm now going to check around this. Everybody's holding it up. I've got my checklist of every student. I've got the steps I'm looking for, which is F, R, A, C, T, and then the answer, which T is my answer in this case. And I'm checking off, which means if I go through and see, is it Andrew? And I see that Andrew, he got it perfect, but let's say Andrew got it wrong. On my marks now, I get to say Andrew got, okay, shoot, that's the wrong answer, and I'm looking through it, and I see he did get the equivalent fraction. So for me, I mark it wrong for equivalent fraction, wrong for answer. Hold on, you hearing me on this? So that means at the end of this lesson, I know who can do what, who did it right, and I know who didn't do it right, and what their error pattern was on one example. Right? It's a very small n, it's just one example, but that trial allows me to say, oh shoot, before we go, I can assign homework for you guys, but for Andrew, I've got to do something different for his homework. And I'll probably give him homework on something else. And if I know the typical error patterns, which would be multiplication, equivalent fractions, they're connected, I probably have a homework ready for me, alternative homework on finding equivalent fractions. If I've taught that long enough to predict these error patterns. Does that make sense? Which means at the end of this day, I've got a data sheet that shows I taught it, who's got it right, and why they have it right. Okay. Now I know we're out of time on this. What did you see? I know it was real brief. What were the components of instruction that I just did? Oh, you're in.
Group practice.
You got it. And we're not going to do another example. You got it. So we did whole practice. Where's it? Independent practice. What else did we do? We did the partner work, which means every student speak every day. Right? Passive learning not allowed. You did the exit. That's the one problem check, that exit slip, and that was on the whiteboard. I did modeling at least 3 times to a similar problem type. I even had a warm-up which set relevance, maybe not real well, but word problems are very, if you've ever written word problems for textbooks, I've been asked several times to write textbooks, and I'm always like, they're all word problem based today, and it's exhausting. Wait, how many times can you find division of fractions within a fraction? Good luck. I mean, there's not many ways to explain it. groups, how many subgroups of subgroups. I mean, that's not a relevant thing. But what I'm getting at, guys, is in a brief time, I can go through that entire lesson plan for you. Those are the components of explicit instruction. All right, let's go to the end of this. I got lots of examples to give you. This is all my stuff. So, your take home. 3 things you picked up from today. 3 things you can leave with today. I'm missing one. Place value. The importance of place value. Give me another one.
Base 10.
Base 10. Is that what I heard?
What did you call it?
You got, on the 10 frames. And 10 frames is for subitization. It works on place value. It's building up to place value. Give me another one. Pat? What? Oh, fract. Sorry. Nice hearing, Brett. My acronym fract. And the array models as well. We did. I feel like my mom every day, right? With the hearing aids that I refuse to wear. So we've got 3. And the whiteboard chat. Oh, you also like the division of fractions approach. Isn't that amazing how many times we've been taught to memorize something, and then someone comes around and says, "Why don't you do it this way?" You're always like, "You shouldn't do it." But yeah, you can do it that way. The first time I showed you, did anybody invert and multiply to check my answer? Yes, because that's the only way to know.
But I did, when we were on the arrays, I went back and checked my answer. But not after.
But now it all makes sense.
Not at all, because this thing, fractions,
All right. Things to take with you before you fill it out.
Please wait.
2 things that you can implement with ease. I want you to consider that. And then the last one, if you still have a question, nobody from here emailed me last time. If you have a question, please don't hesitate to email me or attack me on my way out. So, that being said,
Remember the mid-course feedback, please get that completed. If you signed in with your license and you got a sticker, all you have to do is hand them the sticker at the front desk as you leave. If you signed in using your tag the other way, you have to sign out. And if I can see Sherry McMillan, is she still here? Yeah. And Bridget Anderson, and Lisa Lamberti, and Elizabeth Smith, and Stephanie Peluso. Because y'all got some free little sticks, the short sticks. It's free stuff. Barb got them. Short sticks. You got the short stick.
fill out your interview out and I'll see you in January.
Thank you.
How's it feel?
I'm having problems still getting into my Canvas course. It like passed it, and then I was trying to log into it today, and I couldn't get back in.